I'm here to talk about HTTPS, what, why, and how. So the majority of the talk would be understanding the motivations, what should be the priorities when you deal with HTTPS, the carrots and sticks, and I will give some specific tips about how you would do it, maybe some steps about graduating into it, etc. There's a tiny bit of what HTTPS is, but really tiny. A little bit about me. I kind of jump between security and performance. I was in security for about a decade, and then I went and did Blaze and CTO at Akamai for a few years, building web performance products, writing some web performance books, and now back into security, building security tools for developers that help you fix vulnerabilities in NPM dependencies. So I'm kind of have a little bit of this dual view here from HTTPS. On one hand, I like it and was a champion of it from a performance perspective or from a correct ops perspective, and how do we make it fast? And clearly, there's all the security goals to it. So let's get to it. HTTPS fundamentally is encrypted HTTP, right? So to be clear, there is no protocol HTTPS. HTTPS is simply HTTP over TLS. And throughout this talk, I will say TLS and not SSL if I don't just say HTTPS, because SSL is the old version of TLS and is officially dead with all sorts of vulnerabilities in SSL v3. So if you're using SSL, you're doing it wrong. You should switch to TLS. And in general, although the term has persisted, TLS is the right term for the protocol that you're using. Anyways, I'll probably be using HTTPS most of the time, which kind of makes the problem go away. So what does TLS provide? Fundamentally, you're running HTTP on TLS. Just a quick primer to level set for all of us. It gives us primarily three things. One is identification, authentication. There's a bunch of terms for this. This is about knowing who you're talking to. I'm talking to the server. This is the bank. I can trust its data. And it can, and I can confirm that I'm providing my data to the right authority. Second thing is integrity. So knowing that whatever it is that I'm seeing is indeed the thing, the data that got presented, that got sent to me, and vice versa. When I upload my data, I know the server is going to get the data I sent it. Non-repudiation. There's like more technical term to it, but mostly it's about integrity checking. And last but not least is confidentiality, right? The data that gets transmitted is encrypted, and therefore other parties listening on the wire cannot see what it said. We're very used to HTTPS. It's been around for a long time. HTTPS is primarily, we're used to seeing it in like financial institutions, in banking and the likes. We're also very used to seeing it in shopping and retail sites, at least on portions of the pages. We're going to touch on that a little bit later. Mostly thanks to PCI, again, kind of old news, payment card industry. If you want to accept credit card information, you have to do so on an HTTPS connection. So those industries have moved it. But in recent years, we've seen increasingly more and more websites switch to HTTPS that do not necessarily fit that profile. And this is a lot of the momentum that we're trying to nourish, right? So we've seen it from a bunch of websites. I could have chosen a whole number of them. And in fact, I've done a study that I posted, I think a couple of months ago, that looked at HTTPS adoption over the last year. And in the last year, we have seen a doubling in the adoption of HTTPS. So HTTPS has been around for nearly 20 years. So it took about 20 years to build up to a certain level of adoption, and then it took 1 year to double that adoption, which is awesome. And we're going to talk a little bit about the trends that did this. And this data is corroborated in many ways. This is data from BuiltWith, which is the service that tries to track through browser extensions what our website's made out of, and it tracks HTTPS. So I saw this and it sparked my interest, but I didn't quite believe it because it's one data source. There's always ways to test it. So I checked with the HTTP archive, and it showed that we go from 5.5 to 12.4%. So that's actually more than doubling, almost 2.5 during that same period of time, about a year. So, and since then, there's actually been a bunch of other stats that show sort of the same trend, the fact that HTTPS adoption across the web is increasing. That's an awesome trend. We're trying to build those out. Those stats, as much as they've doubled, are still fairly low. They're still 5.5% of websites versus 12.4% of websites or something of that order of magnitude, which is still very few websites as compared to the, whatever it is, 88% of websites that are not on it. However, when you look at page loads on the browsers, situation is a little bit better, right? So 12.4% of the website as a whole are using HTTPS. However, the popular websites, or the ratio of HTTPS amongst popular websites, notably Twitter, Facebook, Google services, and the like, means that the number of page loads over SSL is far higher. The stats here that you see are, the first one is the stats from Mozilla, the graph there, where you can see we're talking about let's encrypt and how it makes certificates easier and HTTPS easier. But you can see sort of the graph of the percentage of page loads that were SSL. In the Firefox browser, you can see the summary on the side, which is 45% of page loads were on HTTPS. And in Chrome, we got a quote. We don't have sort of the raw data, but we got a quote from the Chrome team that says, we recently hit a milestone that more than half of Chrome desktop pages get loaded. Probably a little bit biased with Google services if you're in the Chrome space. So this is the trend, and it's a good trend, right? This is, the reason I like this talk, or so this topic talk about, is that it's a very unusual opportunity to celebrate a success in kind of getting a security control instituted. There's a few of them these days. There's two-factor authentication, and HTTPS is one of those. And it's because it's so visible and because of a lot of components we're going to review. But the goal really here is to get HTTPS everywhere to improve the web. And my success here is if by the end of this, I have either convinced you or armed you with the tools and the motivations to switch your own website to HTTPS. So we're going to talk about the sticks and the carrots. Why would you want to do it? And then at the end, we're going to talk about tools. Let's start with the sticks. Fundamentally, HTTPS is a security control. It's a risk reduction mechanism. What happens if you don't reduce that risk? What is that risk? The first reason, which in my mind is most important, like this is loosely in order, is protecting user privacy. We're used to talking about privacy, and again, in the context of a bank account, right? This is clearly your private data, even if the balances are nothing to write home about, and you don't want others to be able to access it. We're also increasingly used to seeing it as a part of a social network, right? You're posting pictures of your kids, you're posting personal information. You don't want that information shared. But it doesn't only end there. When you talk about HTTPS and you talk about who is it that might be interested in that privacy, you start worrying about other attributes of your behavior and who do you want to know about them. So for instance, maybe you're a part of a minority, maybe you're gay, or maybe you are a communist, or maybe you are a Democrat, depending which regime that might be considered a problem. And the government might care about those components and act against you. And this has happened. We see this in all the uprising in the Middle East. We see this in activity in Asia. And we definitely have a lot of insights around the activity happening, even if not quite as bluntly, in the US and in the Western world as well. It could also be because of political views. So this might be, again, this is sort of Democrat. This is an example, actually, my sister is this radical left-wing activist in Israel and has gotten a lot of grief from the fact that she's involved in these shared Israeli Palestinian activities, protests and the like, even if they're benign. And it's, in her case, it was kind of hard to hide it. It really wasn't just about the websites she browses, but these types of affiliations are important, and they're something you might not want everybody to know about. As I said, this is something which we attribute to these regimes that are dictatorships and are problematic, and to North Korea or to Russia. But the reality is that it happens everywhere. We've had, of course, Snowden and WikiLeaks that sort of showed us that the US government has a lot of this information and is indeed tracking and looking for information. And we also had, about a year and a half ago, there was this big hack into a security company called Hacking Team in Italy, which they were providers of these types of surveillance tools to governments. And that data was interesting in a bunch of ways. First of all, it's like a little embarrassing for them. They're a security company. They got hacked very royally. But what's important is that in there you saw data that pretty much every government, all the bad regimes and all the good regimes are using this type of practices. So it is very much there. So HTTPS, when you do this, provides us confidentiality. And that's really, to me, the fundamental reason you use HTTPS is for your users to help them protect their privacy. There's a bit of a caveat there with SNI, which we'll touch on about. Second reason to use HTTPS is to protect the users themselves. So users come to you, they browse their site, and if you don't use HTTPS, then your website could become a malicious tool to attack those users. In the confidentiality aspect, when we talked about privacy, we talked about what's called passive attacks. We talked about looking at data, sniffing data, using that information. But many, many of the attacks out there are not passive. They get very active. I'll give you a couple of examples. The first one is China. Again, we're talking nation state. We're not talking something big, but China is notorious for having the Great Firewall of China, and they do all sorts of funky things in that network. But a year ago, there's been a couple of incidents since, but this is best advertised. They hijacked the Facebook login system to DDoS a couple of websites. A little bit odd, this like personal travel blog and this like open source component website. And what they've done is they took websites that use Facebook's SDK on them and they redirected those requests to those locations. So your websites, if they were on HTTP and they were using the Facebook SDK, were used as a mechanism to attack those two other sites or to route your users to make requests against those websites and therefore take them down. And this was doable because Facebook, despite being a great proponent of HTTPS and being secure, their SDK, and this is still true per just like a couple of days ago, I confirmed that this snippet is exactly the same. It adopts the scheme. When you use the SDK from Facebook, it adopts the scheme of whatever is the hosting web page is. So although the Facebook login process would still happen over HTTPS, they're, again, quite good at that, the SDK, the library, the code that performs that and interacts with your page comes over whatever scheme your website did, your web page did. Not entirely sure why this is, and therefore it's susceptible to these types of hijacks. This is not the first time China has done it, and it's not the last one since this happened. About a month before that, they routed a whole bunch of other websites against GitHub, because GitHub represents certain values that maybe that government at the time did not share, and they were looking to do those. And again, we say government, I really don't know who operates the Great Firewall of China, but it was sort of nationwide. In fact, it's common enough they gave it a name. You got a lot in the world of security now, there's these designer vulnerabilities, and you give them a name. You talk about these attacks, these vulnerabilities in more popular terms. Heartbleed, logjam, makes it more memorable. It's called the Great Cannon. So in this case, your website is used to attack other websites. So you're not just protecting your users, they might be blaming you, but really your website was a delivery to make your users attack another website. The other variant of that, I said I'll give two examples, is to actually use your website and manipulate it to attack the actual user's machines. The reality is that browsers are complicated beasts. They're complicated pieces of software and they have vulnerabilities. They all have them, maybe some are better than others at how quickly they handle it, but they all have sophisticated software and they're all written in C or have C components or low-level components, and they all have vulnerabilities. These vulnerabilities are oftentimes quite bad in their implications and leads to some form of remote command execution or substantial breach of privacy on your machine. So if you're using HTTP and not HTTPS, if you are on a malicious Wi-Fi network or a malicious nation-state network, your website can be used to attack those users. Probably not something you want to do. So these are all things that you're susceptible with HTTP, and they're very easy to fix. You just add an S, and that means that your users, when they browse their site, they know that the content that they receive was the content that you sent. You know that somebody in the middle cannot tamper with it. They cannot perform this type of active attack. So why HTTPS 1? Protect your users' privacy. Why HTTPS 2? Protect your users from evil networks. Those are the foundations. I know they're a little bit of repetition and probably you've heard some form of this in the past, but it's important to go back to the basics and understand that those are the core components of why HTTPS is around. When you move aside kind of your duty to your users, the third bullet, sort of the last security stake I'll talk about here, is protecting your business. So not protecting your users is probably bad to your business over time, but implications can be much more immediate. And again, I'll show a couple of examples of this. This is a screenshot from an Xfinity Wi-Fi from Comcast, where if you connect it to their relevant Wi-Fi, and again, there's a bunch of these, I just picked one as a demo, but there's a bunch of these examples from ISPs, where if you browse on their website, that they might interject and add ads or hijack the ads on that page. They might collect the data. What really blew my mind is how Comcast's spokesperson said that they think this is a courtesy because they just sort of add an indication on it to tell the users that apparently didn't notice when they logged on to that Wi-Fi that they are on a Comcast Wi-Fi. And there's a lot of stories around the data that you expose when you work there, but there's also this opportunity to inject. This is relatively benign. This is another example from a Midwest ISP, and you can see the Apple website advertising H&R Block. And that does not happen. The Apple website is not a media site that has advertising on it, so it might not seem odd at first glance, but it's an example of the HTTP website, which the Apple Store has since moved to HTTPS, but right now it's on, back then it was HTTP, and this this ISP has changed the content on that website to have those commercials. So in part, it's about benefiting their business, but this hinders the business of the website that this got presented on. It doesn't align with what you want to build. So these were ISP level, right? We've gone from like nationwide networks to ISP level networks, but all of this really happens even at the low level of a Wi-Fi. So at this point, moving a little bit aside from HTTPS, I'd like to kind of clarify and do a bit of a side on the fact that hijacking Wi-Fi is not that hard. First of all, I'll talk about this in a moment. First of all, it's humans that connect to a Wi-Fi, right? So you browse around, you're at the Velocity conference, you open your list of conferences, and you have a network that says Velocity 2016, and there might be a Velocity conference Wi-Fi right next to it. And the odds, statistics show this all the time, but it's even easy to rationalize, is the odds that you would pick that network and then connect, and if there was no problem, you would just run with it, are very, very high. This happens at airports, it happens in locations that are not there, it happens in Starbucks. There was a wave of these when there was Google Wi-Fi replaced the AT&T Wi-Fi at Starbucks locations. To top that, I don't have a slide about this, but a lot of mobile providers come with built-in SSIDs that your devices connect to automatically, so that they would connect to the relevant hotspot of that network. So it means you can just be in a public location, in some bus station, you can have a hotspot that happens to be broadcasting this non-secure network identifier SSID, and devices of people passing by are just going to connect to your network. So it's much more likely that you have connected to a malicious Wi-Fi network than you might think. And if you haven't, you probably have connected to a public Wi-Fi. And public Wi-Fis are really easy to hijack. I initially wanted to do this here, and then there were some legal problems with this to demonstrate, so I'll show a video instead. This is this researcher team from Berlin that created a little device. They called it News Tweak, and I love the slogan, fixing the facts one hotspot at a time. I'll show you a little video about how this device works and how it hijacks a Wi-Fi in real time. We've got some scary music there in the background to do it. So you can see, they're browsing the BBC website, which again, I haven't checked if it's now on HTTPS or not. And they're using this device. They're just on a public Wi-Fi, and they're using this device to just plug it into the wall. The computer doesn't do anything. The computer stays on the same network. And what this device does is it connects to the same network, the same sort of open network that everybody can connect to. And it does what's called ARP poisoning, which is it fakes, it sort of broadcasts on the network and says, hey, I'm IP, whatever your router IP is. And because of the way networks are set up, and because you could isolate this in Wi-Fi routers, but oftentimes they're configured without it for compatibility reasons, your device would just naturally adapt and find those. And I guess I just missed the punchline here, but what it means is that when you load that page again, or if you now browse it, you can see that you might have received a different headline than what you've seen before. U.S. wants Assange as head of Defense Department. So I'll show you. Twitter details of WikiLeaks activists. Assange as head of Defense Department. Not exactly the same message. Almost. So they go on to sort of show you the IP of those components. So a little bit of an aside, but just sort of to emphasize the importance of it. All these things that we talked about, right? We talked about privacy, we talked about integrity and sort of protecting the users from these attacks. And when we talk about protecting your business and not having it represent something that is incorrect, that is not what you want to message them, all of these can happen at the nation-state network level, it can happen at the ISP level, and it can happen, and usually happens, at the Wi-Fi level from attackers. HTTPS provides authentication, so it confirms to that client that they're talking to the right server on the other side, so IP spoofing goes away. And it provides integrity so that the information that gets sent is the information that gets presented. So from here, we're going to sort of switch to talking a little bit more practical tips. But before I do that, I want to talk a little bit about what does it mean to switch to HTTPS. So what you oftentimes see is what I call partial HTTPS. So you have HTTPS as like a checkout process. This is an example on Adidas, slightly outdated, and it has HTTPS website. It supports HTTPS, and its checkout process is over HTTPS. This is true everywhere because that's what PCI demands. However, much of their website, the majority of the website is on HTTP. And as a result, an attacker could intervene in between. Users go through the HTTP website before they go into HTTPS, allowing an attacker to intervene in between. I'll get back to this one in a moment. A good way to manifest how an attacker would intercept is with a tool called SSL Strip. This is a very convenient tool. You can download it. It's free. It's open source. And what it does, as the name implies, is it strips away HTTPS. So it sits in a network. It acts as a proxy, which, as we've just seen, you can hijack a network or a Wi-Fi to do this. A client would go on, would make a request to an HTTP page. The HTTP page would get to SSL Strip, would go through to the website. The website would return a checkout form with an HTTPS link, but this checkout form was returned over HTTP. So an attacker has the opportunity to now modify that checkout form to be HTTP and not HTTPS. And then subsequently, the checkout would happen there, and voila, you can actually have that action. Now, it could be, by the way, that the website itself only supports HTTPS transactions on those URLs, but that's fine. SSL Strip can fake that. The server doesn't generally verify the identity of the client. So the client has just lost its understanding, or its confidentiality, its integrity, its authentication of the server that it's talking to the other side. So partial HTTPS is roughly equivalent to no HTTPS. The difference is primarily between passive attacks and active attacks. If you're just using HTTPS, if you're using partial HTTPS, then it means you will be protected, the section on HTTPS, from passive attacks, but you will not be protected from the active attacks that can actually manipulate and do this. And again, this happens in the wild constantly, all the time. So when you talk about this, when you think about it, you probably have many, like who here has some HTTPS on their website? Okay, who here has an entirely HTTPS website? Yeah, just one. So it seemed like roughly, kind of rough math, it seems to be about 90%, 95% of the people that raise their hand have a partial HTTPS website. If you want to make that transition, it's hard. You know, it's HTTPS. The links are not always within your control. You have those links everywhere. There are bookmarks, there's links in different pages. Your website doesn't live in isolation. And as I just pointed out in the slide that I skipped, the redirecting to HTTPS is not enough, right? Because somebody would be on a malicious Wi-Fi network, they would browse an HTTP website, and that redirect can now be modified to not go to HTTPS, to stay on HTTP. So there are two things that you can do to prevent that. If you sort of buy into this notion of wanting to stay on HTTP, to switch to a full HTTPS, the first is to not support HTTP. And just sort of make those links die. That's probably not a viable option for many people. And the second is to use a new-ish header that's called Strict Transport Security, or HSTS, the header, HTTP Strict Transport Security. And what this header does is it specifies to the browser when it interacts with you on HTTPS. It tells it, you've seen this website on HTTPS now. This website should only be accessed on HTTPS. So it means if a user has browsed your website on HTTPS, the browser will cache that knowledge, will remember that this website is an HTTPS website. And if that same user is now in a malicious Wi-Fi network and the attacker is trying to get them to go to HTTP, the browser will not allow it. HSTS is sort of a good way to motivate, to move your users over time, and it will secure your users and make sure they're on HTTPS as long as their first interaction with your website for that HTTPS was on a good Wi-Fi network. And that's a pretty fair trade-off, because most of the time you're not browsing on a malicious Wi-Fi network, you're still on a legit one. Two things to note is HSTS is not easily purged. So you need to consider this. Don't introduce HSTS before you know the stability of your HTTPS is good and that you're not going to take away HTTPS, otherwise you're going to be in trouble. And the second is that HSTS is still not supported across all the browsers, but it's increasingly supported across sort of many browsers, so it will still give you a lot of access. Wow, I'm way behind. Rush through those. So those are the three reasons that are more sort of security sticks. The last stick that I have before I switch to the carrot is browser security indicators. So I'm going to use Chrome as an example. Firefox is going through a similar process, and IE a little bit further behind. So we've all seen this, right? You've got an HTTP website, you browse to it, you've got a little icon, it used to be a little page, now you have a little eye there. There's no comment on security, right? This is a site, kind of your call. If you go to an HTTPS website, you get this green lock. If you've got like extra organizational validation, extended validation, you get like an extra good green bar that says you're really secure. And if you have an imperfect HTTPS website, you get all sorts of problems, right? You get some form of error, some indication, maybe a little yellow triangle. And this is tricky. I mean, this HSBC website, which again has since been fixed, I'm kind of catching this because they move all the time, got the yellow icon because it was using a SHA-1 signature or sort of crypto algorithm, and which is not considered secure, but it is still more secure than not encrypting at all. So why doesn't the browser communicate that? So that's sort of one side of the problem. The other side of the problem is people take this lock, they take the HTTPS indicator, and they say, this is a secure website, right? You've just told me that. You've got a little green lock there. When in fact, HTTPS is only one aspect of security. And there have been some very well-known, well-advertised, and there's a constant stream of security hacks and attacks and breach of security issues of websites that have been on HTTPS. We've seen this one, we've seen Ashley Medicine, which is a big one. LastPath had 2 in the last year. So HTTPS does not equal secure. There are many attributes of secure, and it's just one attribute. But what I can say is that HTTP is insecure, because that is definitely not securing the relevant channel. So browsers have understood this for a while and are now committed to communicating that to the users. There have been statements, you don't have to read the exact ones, but from Mozilla, from Chrome, to talk about how people don't perceive the absence of an icon. You know, what they have today on HTTP is not good enough, and that they're committed to start removing capabilities from the non-secure web and market as such. And this is already happening. In late 2015, so this is a good year, almost a year ago, we've already seen Chrome remove those icons, those yellow marks, to say, well, you know, this is not, an imperfect HTTPS is not worse than HTTP. It's just the same. And what's coming next, and this is coming actually in January, so very imminent, is more explicit statements about an HTTP website that it is not secure. Now this screenshot got me really excited at first, and I got it a little bit toned down. So what you can see at the top is that Chrome 56 that would be released in January is actually going to say not secure on an HTTP website. It's not going to say it blanket across all HTTP websites. It's going to say it on HTTP pages that require a field that looks like a username or a password field or a credit card field. So it's not quite there, but that is the destination. And eventually, all HTTP websites would be marked as such. So if all of the user privacy and security reasons were not sufficient, hopefully this would motivate you over the edge. So yeah, I'm again kind of way behind a little bit on my schedules. So these were all negative reasons, right? These are all the sticks. What bad thing could happen if you don't switch? Let's talk a little bit about the positives. You know, why should you move to HTTPS? What would you gain, not just lose? Because those are more fun and they're more immediate and easier to justify. So the first one is HTTP 2. Who here heard about HTTP 2? Okay, I hope even the people that didn't move their hand. So HTTP 2 in a nutshell is a better version of HTTP. It supports multiplexing for many requests at once, header compression, server push, a whole bunch of technical optimizations that fundamentally just make it better, faster, more reliable, more tolerant to networks. Just a side note, HTTP 2 is a newer and standards-based version of Speedy, so if you've heard of Speedy, HTTP 2 is the next gen of that, if you will. Now, HTTP 2 is awesome. HTTP 2 is here today. Browsers support it, CDNs support it, many server plugins support it, so you can use it today. However, HTTP 2 is binary, so you can't just forward it over port 80. You can't just communicate that as is. And HTTP 2 is new, so if you have servers in between, they do not understand. Odds are that those proxies in your company, that those proxies at the ISP are not yet updated to understand HTTP 2. So as a result, HTTP 2 is likely to fail. It's likely to not succeed, and in fact, that has been the barrier to improving HTTP over the years. And the trick that really got through it, that broke through it with Speedy, was to say, well, is there some technology out there that allows us to create a tunnel between the client and the server that nobody can see anything in between? Lo and behold, we have that. It's called HTTPS. So as a result, HTTP 2 is actually, in practice, a better version of HTTPS. It's not technically, the protocol supports HTTP on it, although there's a lot of debate about that, but in practice, all those that implemented it only support HTTPS. So that's carrot number one. Carrot number two, service worker. Who here heard of service worker? Okay, a few more. You know, if you haven't heard of service worker, I would encourage you, again, this is not a full session on it, but you know, fundamentally, we want an offline web. We had appCache, which is not good. But we do want that offline web. We want the ability to use applications when a user is not connected or connected poorly. We want them to be fast. And Service Worker gives us this. It's this JavaScript proxy that intercepts all the requests in the browsers and allows you to cache them in a scriptable cache and register for push notifications. It is awesome. It's also a progressive enhancement component. So you would go off, load a web page, and a piece of JavaScript on that page would now install Service Worker. And next time this page loads, Service Worker will be installed, and it would now be able to manipulate requests and work on those. So no prompt installation, and it persists forever. It doesn't go away. And that sounds good until you start putting your security mindset on. And that basically means every cross-site scripting has now become a persistent cross-site scripting in that user's browser. It's kind of cache poisoning built in. And it means if you could do this over HTTP, it's one time, all you need is one time to be on a malicious Wi-Fi network, and somebody can install a pretty massive piece of JavaScript malware on your website forever. So as a result, Service Worker requires TLS. It does not work over HTTPS. It will not work over HTTPS. That's a core component of it. You still need to be aware of cross-site scripting and need to be careful because it would still overpower, make them more powerful, but it would not be susceptible to malicious Wi-Fi networks. And HTTP2 and Service Worker are kind of the early indicators of a series of powerful features, and the browsers have both committed to only allowing these powerful features over HTTPS. Geolocation has already moved to be TLS only. A bunch of the others are there, and you will increasingly see any feature that somebody can conceive some form of attack that would be problematic enough would switch to being HTTPS only. And then the last carrot that I have is less technical, but rather more on the business side, and this has been true for a while, but apparently it's increasing in its impact, which is that Google ranks HTTPS higher. So Google has made that statement explicitly in May of 2014, I think, that they would use it as a signaling component with an increasing level of weight. So they started off having it be very, very light. If you have two websites that are effectively the same, but one is on HTTPS and the other isn't, it'll get bumped up. And nobody has visibility into sort of the secret sauce that they build, probably not even the Googlers there, but the weight of it is declared to be increasingly there, and you see this. You see more and more of those HTTPS results coming in. So HTTPS impacts SEO, and if the security concerns have sort of convinced those that are more security conscious amongst you, and if the kind of geeks amongst you, the sort of web geeks like myself, are excited by the web features, this might be what motivates your business. So, I kind of glossed over just bad time management here over the carrots, but I think they're both equally powerful, and you need the two of them. And between the carrots and the sticks, hopefully you care enough to want to move over HTTPS. And now the question is, so you care this much, how much effort is it? If it's this much effort, you're still not going to do it. But if it's this much effort, if it's less effort than the level of caring that you have, then you're more likely to do it. And fortunately, over the last couple of years, primarily, there have been huge improvements in how easy it is to do HTTPS. So I'll talk about a couple of handy tools. The first one, and probably most kind of well discussed in this community, is Let's Encrypt. So Let's Encrypt is a new certificate authority. It was driven by EFF and Mozilla and Akamai, and it basically is a free CA. It's free, it's automation friendly, it is amazingly easy when you start it. I didn't have time to it, but you can actually run a browser on a machine that represents a domain. You just change the DNS to point to that domain, to that little server that you have. You run a single command, it does all the verifications, and it gives you the certificate back. It has auto renewal, super automation friendly, copy paste materials, no need to talk to a human. It's all like very easy, very friendly to use, and it's free. And that has really opened up this world of ecosystem that now WordPress has integrated Let's Encrypt, a bunch of CDNs have implemented Let's Encrypt, because not only does it make it easier for you to provide and build those certificates for yourself, it makes it easier for these platforms to build them in. So you should use it because it's free, it's automatable, it's not in beta, if you're wondering, because it's been in beta for a good period of time. It's already trusted in the browsers via an intermediate certificate, so it just means you need to have a slightly bigger certificate file, and then it'll be trusted in pretty much all the browsers. And really, I would say that eliminates any reason around certificate complexity for you to not use HTTPS. So that was one sort of cost reason that people would typically tout around why not HTTPS. The second reason is delivery cost. And the good news is between compute improvements, between Let's Encrypt and other components, those are also going down. The ones that led the charge here, and this has been true for a few years, is Cloudflare with their universal SSL, which gives you free SSL. Today, in many of the different services, SSL is anywhere from cheap to free as part of the package. I'll point out one small thing around Cloudflare is that note that if you are using the Cloudflare super easy plug-and-play HTTPS, oftentimes if you didn't change anything in the origin, it means you're using HTTPS between the Cloudflare server and the client, but you're not using HTTPS between the Cloudflare server and your origin. So you're protecting against some things, but not against others. It is better than nothing, but it is nowhere near sufficient. You should aim, you should strive to get the full set experience, the full sort of sequence, the full network encrypted, and Cloudflare recommend this as well. Yeah, I don't have time to dig into this too much, but it's worth noting that this will get increasingly easy, and the reason for that is SNI. SNI is short for server name identifier. Today, when, say, you're using a CDN, and you've got two websites, and both websites resolve to the same CDN edge IP, so they make a request from that IP. If you're using this on TLS now, how would the edge server know which certificate to return? That certificate is used to identify. You don't want those two websites to be able to fake each other. You need to know to return the right certificate. How do you do that? And the solution to that was to add the server name to the TLS protocol, despite the fact that it slightly exposes, slightly reduces confidentiality. And that's been around for a very long time, and it has the whole flow here, but unfortunately the web moves slowly, and therefore old clients, Windows XP, Android 2.3, in apps, Android 4.4 as well, do not support it yet, and IE7 and older. So I guess my suggestion is non-SNI clients, all these clients are decreasing in popularity, but it's one of those things that's just sort of dragging on, and we need to decide to kill them, kind of like IE6. And once you look at your analytics and you're comfortable enough that you're okay with dropping those clients, then you can switch to these solutions that are SNI only, and therefore are cheaper to free, and allow you to not have, otherwise you need dedicated IPs, it gets more expensive for the delivery entities to give you those. Yeah, and just a couple more tips, as you sort of make that transition. When you do implement TLS, it's fairly complicated. There's a lot of different knobs and dials you can choose. If you're using some service provider, it would be probably, it would handle those things for you. If you're not, SSL Labs has SSL Test, which gives you a very easy score to say what are you doing well or what are you doing wrong, and good advice around how do you configure your TLS correctly. And if you're wondering about all sorts of fancy, you want to take it up to the next level and talk about speed improvements in TLS. There's a website called Is TLS Fast Yet that Ilya Grigorik set up, which is maintained fairly well with a bunch of the capabilities that different web servers and different network providers have around HTTPS, that again get a little bit fancier in terms of their performance attributes, how do they merge certificates together, what cipher protocols they provide. And because those are evolutions and they're extensions to TLS, not everybody supports the same thing. So it's a good website to consult after you've already switched to HTTPS. How do you make it work as best as you can? Yeah, so that's basically my points, right? Why switch to HTTPS? First of all, to make yourself more secure for your users and for your business. Subsequently, to be able to tap into the world of the modern web and all these great new technologies that are coming along. You want to avoid being marked as not secure by the browsers over the years, and you want to be ranked higher in HTTPS. And really because many of the objections that you historically remember and you might have encountered or you might hear when you come in to champion this in the organization are increasingly going away. So if you get those objections, if you get the pushbacks, check if they're still there or if this is just historical context. That's it for me. I hope this was useful. And I guess I've got maybe like a minute for questions. Yeah, a couple of questions. Any questions? Yeah. Yeah. So the question is, how do I feel about internal communication for HTTPS? I'm for it. I feel it's increasingly important when you switch to increasingly less trusted networks. So there's HTTPS for your internal like intranet. Those I think are very important because your intranet is increasingly not an intranet anymore. People are everywhere and they're browsing to it, and if they're over VPNs, there's still substantial opportunity for attackers. Even if they're inside attackers, they're not necessarily the most trusted of the employees. Second version of that is whether you use HTTPS between your microservices, for instance, and things like that. In my company, we do that. We have HTTPS communication between every microservice, and I think over time that's a worthy investment because it gives us maximum flexibility around choosing where those components run. And I think typically when you would set it up, you would have all the knowledge and the insight about saying, hey, all these things run within the same VPC or within some virtual network that they're connected. Maybe they're even running on the same machine. It's okay to not secure those components, and then that decision is forgotten. And that consideration is forgotten. And later on, for all sorts of scale and operations reasons, somebody moves those services, they run in different systems, they run independently, and suddenly you lost that component. So I think once you invest with Let's Encrypt, with the compute cost is negligible. So I would say if you make the one-time investment to make it easy, just like you make it easy to set up a microservice, you just default to making that microservice HTTPS. Even if it's with a self-signed certificate or something like that, then it shouldn't add ongoing effort for your deployment setup for new services. Other questions? No? Okay. Well, I hope you found this useful, and I'll be around if you have any questions to come up with. Thank you.